All right, let's look at the problem set 5, problem number 7. All right, it says this. Jack has a 25 chance of winning each hand of blackjack he plays. If he has $150 and bets $50 a hand, what is the probability that he will still have money after the third hand? All right, so we're going to consider, the event would be he will have money after the third hand, right? So I'm going to just call this guy, so event E, right? And what would be the opposite event? So if you look at the probability of the opposite event, so the opposite, the notation is put the little c, so it means a complement. All right, opposite event would be he has to lose 3 consecutive times in a row. So you have to lose the first one hand, the second hand, and the third hand. That way he can lose all $150, right? So the opposite would be probability of, I don't know if it's a good notation, but you're going to lose the first hand and lose and lose. Right, so that will be the probability, right? Right. So since he has a 25%, right? Remember that 25% is same thing as a 25 over 100, which can be simplified as 1/4. So he has a 1/4 probability of winning. So the probability of losing would be the other half, so it's going to be 3/4. So the probability of losing would be 3/4. So it's going to be 3/4 on the first hand. And you have another 3/4 probability of losing the second hand. And then you're going to have to lose again. So it's a 3/4. Right? So this is going to be 3 times 3 times 3 is 27. And divided by 4 times 4 times 4 is 64, right? Then the probability of the actual event that we're interested in would be always 1 minus the probability of the opposite event. So you have a 27 over 64. Then you can see that, let's see, do the common denominator, which is 64. So you have a 64 minus 27, which is equal to 14 minus 7 would be 7, and 5 minus 2 would be 3 over 64. Right? So answer is D. All right, that's it. I hope that this was clear.